Okay, so chapter 11's main focus is going to be on these special set of different types of graphs known as conics. And the first type of conic that we're going to see are called parabolas. Now, you've definitely worked with parabolas. You've seen exactly what these equations look like. But we're going to focus more on, how are these parabolas constructed? And by definition, how are they been created? So you may have said, hey, I know that a parabola looks like something of the form ax squared plus bx plus c, but you may never have seen exactly why parabolas take that form. And that's kind of what we're going to be doing today, right? We're going to define what a parabola is, like how is a parabola defined? And then based on that definition, we're going to notice that it just so happens to be the family of functions that are quadratic, which have x squareds and y squareds in them. Okay, so let's start off just by doing what I said. We're going to define what a parabola is. So by definition, a parabola is the set of all points in the plane that are equidistant from a fixed point F, and this fixed point that we're calling F, that's called the focus. So that's known to be the focus, okay? And so it's equidistant from a fixed point focus and a fixed line, let's call it L, and this is called the directrix. Okay, so this is literally what a parabola is, right? It's kind of like we want all the points in a plane where when you take that point, the distance to the focus and the distance to that fixed line always stays the same. So just to kind of give you visually how this works, so here's a visual of it. And then obviously we'll use this picture again to kind of make more comments about it. But if you think about it, if let's say I put the focus here, and let's call this the focus, and then let's just give it some coordinates, and I'm just going to call it 0 and p. So I'm just saying whatever it is, I'm moving up p units, right, from the origin. And then what we're going to do is we're going to say, okay, well, and then the directrix I'm going to put down here, and I'm going to say we move down p units to get to the directrix. So we'll call this the directrix, okay? Now, what we're then saying is, and by the way, this looks a little longer than that, which is fine. We understand, right? These distances are supposed to be the same, right? So then what happens is we create a parabola where it takes on this shape. So what are we saying here? All the points on this parabola have the same distance away from the focus and this line. So for example, if I just pick this point, which is on the parabola, this distance and that distance are the same. Okay, and then if I pick this point, for example, this distance and this distance. Now look, we're not saying that these distances are the same, it's just that distance and that distance are the same. So what is it that we notice? Why does the parabola take on this shape? It's because the further I move up, or the more I move to the right and left, this has to go further up, so the distances stay the same. So that's kind of what's going on here. So by definition, we could see that when we define the focus and this is our directrix, we have pretty much all the points that are equally distant away from the directrix and to the focus gives you that shape of that parabola. Okay. One other comment I want to make is this axis right now, which is the y-axis, notice how it cuts the parabola in half. This is known as the axis of symmetry for obvious reasons, right? Because if I reflect the parabola off of this line, I'll get itself back. So it is symmetric that way. And then, of course, this is a horizontal line, which is y equals to negative p. Now, notice how the way the parabolas have been defined, and this is naturally true, obviously, the focus is always kind of like on the inner part of the parabola, right? The parabola could not open downward. It would be impossible because it cannot intersect the directrix, because if it does, then the distance to the directrix will be 0 and the distance to the focus will be greater. So obviously it has to open away from the directrix and the focus will be inside of it, right? Or else it'll fail the definition. Okay? So with this said, now what I want to do is I want to pretty much talk about how we come to the formula of this parabola, right? By definition. So let's talk about this. So the derivation of the formula. So how do we find the equation of this parabola? So literally what we're going to do is we're going to take the definition of a parabola. So by definition, what is it that we need? I need any point on the parabola. So I'm going to say, look, just to account for all the points on the parabola, I'm going to have to make it generic. So I'm going to say, let the point P, which has coordinates x comma y. Now the reason why I'm calling this x comma y is because there are infinitely many points on this parabola. So obviously when I do this, I'm just saying, look, this is just any arbitrary point on the parabola with, or in fact these are all the points on the parabola, and we're going to use the definition then. So we're going to say let P, which the point which is defined as x comma y, be any point on the parabola So then what do I want to do? Now I want to find what? The distance. So let's say that this is point P, which we're saying x comma y. So now what do I need to do? I need to find the distance from point P to the focus, which we know how to find that distance from point P to the focus. That's just using the distance formula. So we would say that the distance from P to the focus is, and if you remember, what is it that we did? We called the coordinates of the focus 0, comma P, okay? So the distance from x, y to 0, P, using the distance formula will be what? It'll be x squared, because what would it be? It'll just be x minus 0, which is just x squared, plus y minus P quantity squared, okay? So then what else do we need? We also need what? The distance from this point to the directrix. And notice how what we can say for a fact is what? We know that on this point of the directrix, what is the x value? The same as this x value. So it'll be x, comma, right? Because I'm just moving up and down. And then what would the y value be? It'll just be negative p, won't it? Because that's y is negative p. So I want the distance from xy to x negative p. So what we're going to say is, and the distance from point P to the directrix, which we'll call it L, is the following. Square root of, and it'll be what? X minus x squared plus y minus negative p squared. And what do we know about the x minus x? That'll zero out, and this just literally becomes what? Square root of y plus p squared. And then what is it that we know? Square root of y plus p squared becomes just y plus p, except I'm just going to put absolute values about the y plus p, because remember, this is distance, and if p is a negative number, we could potentially have y plus p become a negative number, but we'll take the absolute value to make sure that the distance stays positive, okay? So what have I done so far? I found the distance from P to F and the distance from P to L. Now, by definition, what do I know about those distances? They must be equidistant, which means these two have to be equal. So we're going to say, look, by the definition of a parabola, we can then say what? These two distances are equal. So the square root of x squared plus y minus p squared has to equal to what? The absolute value of y plus p. Okay? Now, with that said, if that's the case, then what is it that we know? Now we want to solve for y or x in this case. So what's the first thing I'm going to do? I'm going to square both sides. And look, when I square both sides, what do I know about this absolute value? Anytime you square something, it's always going to be positive. So what could I do to the absolute value? I could just drop the absolute value, because I know that y plus p, even though that's might be a negative number, when I square it, it'll be positive. And then this side will just become what? X squared plus y minus p squared. So now we'll continue on, and we'll just continue simplifying. And by the way, just to point this out, notice how the x squareds are showing up, right? Except it looks like we have the x squared and the y squared, but one of them is going to go away. But we could see how the x squared is popping up. So if you're ever wondering, hey, why are parabolas defined as functions of quadratic form? Well, notice how we're using the definition and these are popping up. So if I square this, what do I get? I get x squared plus y minus p quantity squared is y squared minus 2py plus p squared equals to, the right side becomes what? If I square that, it'll be y squared plus 2py plus p squared. Now look at how nice this is. A bunch of things are going to cancel out. The y squareds are going to cancel out, because if I subtract them, they're gone. The p squareds are going to cancel out. If I subtract them, they're gone. The 2py, they're not going to cancel out. So if I add a 2py to both sides, what do I get? I get x squared equals to 4py. And remember, what is p? Just coming back to this, p in our picture is what? It's actually the distance from that point, and hopefully you guys know what that point is called, right? That, if you remember, this is the vertex of our parabola, right? It's basically the maximum or minimum. It's the distance from where? From the vertex to the focus and the vertex to the directrix. And obviously the vertex is on the parabola because that distance is, this is an equidistant, right? The distance from the vertex to the focus and the directrix is the same. So that's what P is. So by looking at the formula, you know exactly this is the distance we travel to get to the focus and the directrix. Okay, but here is what we have, and notice how it is of the form x squared. So we're starting to see, hey, wait a minute, parabolas are definitely, by definition, right, we get x squared out of it. Okay, now some other books, I mean, this is the format that we're mainly going to work with, but if you see this, or some other books say, hey, I'd rather just solve for y, right, because we always see functions as y equals, some books write it as 1 over 4p x squared. And hopefully you understand that these two are the same thing, right? There's no difference, right? So because what did they do from here to here? All they did is divide both sides by 4p. Okay, so there you have it. We pretty much derived the formula of a parabola. Now the next thing we're going to talk about is, now I'm going to basically give you the most generic, or I'm going to give you guys all the formulas of parabolas. So I know that we only proved one of the, or we derived only one of the formula, but all the other formulas are going to be identical. So here's what I mean. So let's kind of generalize it. What we just derived, here's what we said. Parabola with a vertical axis. And then when you hear a vertical axis, what is it that we're saying? When I talk about parabolas with a vertical axis, that means these are the parabolas that open upwards and downwards, and you'll see it in a minute. So we know that the graph of x squared equals to 4py, and we already proved this, right? So this is a parabola. So we know that this is a parabola because we even derived it, with a vertex of v 0, 0, and if you remember in the picture that I used earlier, I literally put the vertex at the origin. See, if I go back here, so notice how the vertex is at the origin. So we specifically found the equation of the parabola where its vertex is on the origin. Now, how will the formula change when the vertex isn't at the origin? We'll talk about that later, but I'm sure you guys can guess through transformations of how the formula would change. But that's not difficult, right? Once we know this, we can move the parabola around anywhere we want, because we're very good at graphing functions using transformations, right? In fact, we kind of do everything with transformations anyway. So that's the vertex, and then we have our focus. And where would the focus be? The focus, if you remember, we said is at 0, p. And if you remember, that was the distance I had to travel from the vertex to get to the focus. And so notice how if the parabola is opening up and down, if I'm at the vertex, I need to travel up and down to get to the focus, which that's why, notice when you travel up and down, your x values don't change. It's just your y value that changes, right? So it'll be 0, pi, which means I moved, what, p units away from the vertex. And then the directrix, what does that mean? To get to the directrix, I have to travel in the opposite direction of the focus from the vertex. So the directrix, and if the parabola is opening up and down, my directrix is going to be a horizontal line. So it'll be y equals to negative p. Okay? So with that said, now there's two possibilities. Okay? So what we could say is the following, is if p is greater than 0, that means if p is positive, so if p is positive here, then what is it that we know? The parabola opens upward. Okay, so what is it that we know? It'll be something like this. We know that if I have x squared equals 4py, the vertex is at the origin. If p is positive, what does that mean? To get to the focus, I have to move 0, p, and if p is positive, it's going to put me up. I'm going to be moving up, right? So this will be 0, p, which is our focus. And then what would directrix be? The directrix will be where? At y, so I move the distance of p, and then the directrix will be where? At negative p, so it'll be at y equals negative p, and then of course we have our parabola that opens upward, right? Now, what if p is negative? Well, I'm sure you can guess. If p is negative, then that means parabola opens downward. So if p is less than 0, the parabola opens downward. Now, why is that? Well, let's see what happens here. Because we're still saying the focus is where? At 0, p. But what kind of a number is p? P is a negative number. So here's my vertex. That'll still be 0, p. How come? Because p is negative, which means now we move down to get to the focus. And then what would y equals negative p? Well, if p is a negative, two negatives make it a positive. So this would put me... See, I'm writing negative p only because what is it that I know? A negative and a negative makes it a positive. But the point I'm trying to make is now it's like the directrix and the focus have been swapped, right? So this is y equals to negative p, which now, if I draw my parabola, now it has to open downward, right? So it's kind of, that's what's happening here. So remember, when I write this negative p, the reason why I write it like that is because when I'm above the origin, my y values have to be positive. So if I were to write p, that would be contradictory, because if p is a negative, how do I make it a positive? Put an extra negative in front of it, okay? But I'm just writing it in this way so you see that this applies to all cases, right? So the value of p is what determines that, hey, or the sign of p is what determines if the parabola opens upward or downward, okay? So with that said, let's look at a couple of examples, and then we'll talk about parabolas that open sideways. But just to comment on this, I'm not going to show what the formula of this is, because it's literally the same way we found the formula of that, right? Except you'll notice that when you find the distances, you'll have an extra negative in there. So I trust you could do this. And we'll even talk about parabolas that open sideways. Once again, I won't derive those formulas. I'll just give you the formula, because the way you find them is identical to the way we found the formula for the upward case, okay? So if you'd like to see it, or if you want to try it out and you get stuck and you have questions for me, don't hesitate to reach out, and I'll be more than happy to explain to you how you'd go about finishing that off. But the steps are identical, right? If you just follow the same way I did the first one, you'll be fine. So for example 1, we're going to say find the equation of the parabola with vertex (0, 0) and focus 0, -8. Okay, so first of all, before I mention anything, what I know is that this parabola opens which way? up or down, right? How come? Because look, from the vertex, I traveled up and down to get to the focus, right? Because notice how the x value stayed the same. So what I say to myself for problems like this, just to make things easier on me, I automatically say, hey, look, I know this is a parabola that opens upwards or downwards, which is going to require this formula. So I just write that formula out. So then I need to decide, well, I need to figure out what P is, because if you look at this, I have 90% of the formula there, right? All I need to do is figure out what P is. Now look, P is the distance we travel from the vertex to the focus or vertex to the directrix, isn't it? So what is it that I know? I know that the distance I travel is what? Is 8 units, okay? But remember what we said. Now we need to decide, is P positive or negative? And in this case, if you remember the comment I made earlier, is what? The vertex or the parabola always opens in the direction of the focus. So if I travel up to get to the focus, what does that mean? The parabola opens upward, which means my P should be positive. If I travel down to get to the vertex, my parabola opens, or sorry, if I travel down to get to the focus from the vertex, my parabola opens downward, which means my P should be negative. So look, from the vertex to the focus, I go down 8 units. So since I go down 8 units, what does that mean? My parabola should open downwards. Therefore, so we're saying parabola opens down, which what does that imply? P should be less than 0. So if that's the case, how many units do I travel to get to the focus? 8 units down. So what does that mean? P is -8. And once we have P, then we're pretty much done, because what is the equation of this? It'll be x squared equals to, if I plug in -8 for P, I get -32y. And there's our equation, okay? So we could see how once we have P, then we have the equation ready to go, okay? So let's look at the second example. Find the focus and directrix of the parabola y equals to -5x squared. Okay, so if you look at this, the format that this has been written in is fine, right? I mean, it's not incorrect, but we know that first of all, if I want, I could write this back in what? The x squared equals to 4py form, right? So I could literally say what? This is the same thing as what? X squared equals to -1/5y, right? If I just want to look at make it look like that, which it's up to you. It doesn't matter. You could leave it like this or like that. But since this is kind of like the formula that we're mainly using, I'll stick to this. So what do I know about this? Since this is my 4p, isn't it? And the -1/5 is where my 4p is. And since this is negative, what do I know? This parabola is going to open downward, which means I need to travel down to get to the focus and I need to travel up to get to the directrix. So what I need to do is I need to figure out what P is to be able to do this. So if you compare this to that formula, see, what is it that we know? 4P equals to what? -1/5. Now why did I write it like this? Because whatever this is 4P, isn't it? So once I could figure out what P is, then I could easily find the directrix and the focus. So I could solve for P, divide both sides by 4, which P is -1/20. So what is this saying? If my vertex, and by the way, this formula is designed in a way as to what? My vertex is at the origin, right? So obviously the vertex at the origin. So if the vertex is at 0, 0, to find my focus, I need, since this opens downwards, I need to travel down. So the focus will be what? 0, -1/20, right? And then to get to my directrix, which would be a horizontal line, I would have to move up 1/20 units. So if I go from 0 up 1/20 units, so the directrix will be what? Y equals to 1/20. And so there you have it. So we found the focus and the directrix of just by literally looking at this equation. And remember, the key was finding what P is. Once you find P, then you're good to go. Okay, so with that said, let's move on to the parabolas that open sideways. So the parabola with horizontal axis. Okay, so now we're going to focus on parabolas with horizontal axis. Now when we say horizontal axis, what does that mean? These are parabolas that open to the right and to the left, right? So we're going to say a parabola with a horizontal axis has the equation y squared equals to 4px, which, so notice how is this different? If you look at the earlier one, the ones that open up and down, it was x squared equals to 4py. And I promise you, if you take the same approach, except now you draw your parabola opening to the right or to the left, you'll notice that your coordinates for the focus and your directrix will now be a vertical line. That will change, but if you do the same approach, you'll arrive at the y squared equals to 4px. But remember, what is this here again? This has with a vertex, the vertex still at the origin, 0, 0, except now we're moving which way? We're going to move sideways to get to the focus. So the focus will be what? It'll be p comma 0. So now notice how I'm moving right or left to get to the focus, which naturally makes sense because now the parabola is opening to the right or to the left. And then it has a directrix. And look, if my parabola is opening sideways, it's impossible for the directrix to be a horizontal line because the directrix and focus can never ever intersect the parabola. So if you think about it, if a parabola opens sideways, the directrix has to be vertical and it has to be on the to the left or to the right of the parabola depending on which way it opens. So it'll be x equals to negative p. So notice how this becomes a vertical line. So we can now say, look, if p is greater than 0, what does that mean? Parabola opens to the right. Okay, so literally what we're saying is here's how it's going to look. If I'm drawing this out, we have our vertex still at 0, 0, and if p is greater than 0, what would my focus be? It'll be p comma 0, so that means I'm going to travel p units to the right, so that'll be your focus, which will be p comma 0, and then what do I have to do? I have to travel p units to the left, and hopefully you could see why my line has to be vertical, because the parabola is opening that way. And so that's what we get. Now, when will the parabola open to the left? If p is less than 0, right? So parabola opens left. Okay, so what we're noticing is it'll look something like this. If here's my vertex, this would be what? The focus, which would be p comma 0. Remember, once again, p is negative, so p comma 0 would mean I'll travel to the left. This would be x equals negative p, because look, if p is negative, with an extra negative we'll make it positive, and then this opens to the left. Okay, so that's how this looks. So just real quick, whenever you see x squared equals 4py, that's a parabola that opens up and down, and p determines if it'll go up or down. If you see y squared equals 4px, that's right or left, and then p decides if it opens to the right or to the left. Now, hopefully you see that p is probably one of the more important things that we need to know of, right? And then we'll talk about something else shortly about some other characteristics, especially when it comes to graphing parabolas. It'll make things easier on us, okay? So let's move on to example 3, which says find the focus and directrix of 2x plus y squared equals to 0. So what is it that we notice? If I look at this, even though it's not in the form that we like yet, we can clearly see that, hey, this is a parabola that opens to the right or to the left. How come? Because the y is squared and the x obviously is just linear, right? So this is going to be a parabola that opens sideways. So if I were to solve for this and write it in the format we like it, what would this be? This would be y squared equals to negative 2x. So now right away, what could I see? This is a parabola that opens to the left, right? And if it opens to the left, I just need to figure out what the focus is. So I need to travel to the left to get to the focus, and I need to travel to the right to get to the directrix. So I just need to figure out what P is. And once again, remember, this came out of the 4P. So we know that whatever P was, and I multiply it by 4, it equal to negative 2. So now I'll be able to solve for P, which if I solve for P, what do I get? P is equal to negative 1/2. So what is this saying? If you travel half a unit to the left, you'll get to your focus. And once again, if you look at this, my vertex is where? It's at 0, 0. So from the vertex, travel half a unit to the left to get to the focus. So the focus would be what? Negative 1/2, 0. And then I'm going to need to travel half a unit to the right to get to the directrix. And since this opens to the left, my directrix is going to be a vertical line. So the directrix will be x equals to 1/2. So those are the two facts we need, the focus and the directrix. Okay, so let's move on to the next idea, which this is going to be important in a sense of when we're graphing parabolas. Because look, we could always locate the vertex, and then if I could locate 2 more points, then I could easily graph the parabola. So this is called the focal diameter. So let me describe to you guys what a focal diameter is. So the focal diameter is a length. So this is the length of the line segment where its endpoints are on the parabola and the focus is its midpoint. So the focal diameter is literally the length of a segment. So if I have let's draw out an example. So if I have a parabola that, let's say, opens to the right, here's what I know. If it opens to the right, we know the focus is going to be in here, somewhere in here, right? So I'm just making that up. Let's call that the focus. And we know that this has coordinates p, 0. And so what is the focal diameter? The focal diameter is this length. Now, so this whole thing right here is what? That length is the focal, I'll call it FD for focal diameter. Okay, now why is that important? Because if I know the length of the focal diameter, then I could locate 2 points on the parabola for free. Because if I know, and since the focus is the midpoint, if let's say the focal diameter is 4, for instance, I'm making up a number. What does that mean? From the focus, I would need to travel up 2 units to get to a point on the parabola, and I would need to travel 2 units down, which 2 units up, 2 units down gives me a total of 4, right? So we're basically locating points for free. Now, why do I say it's points for free? Because just by looking at your equation of our parabola, then we could easily figure out what the focal diameter is. So look at what happens here. To locate these points, so we know that this equation, since I use the right parabola that opens to the right, looks like what? Y squared equals to 4 pi x. Okay, now look, to locate these points on the parabola, what do I know about the x value? It's the same as the x value of the focus, right? Because I'm moving up and down. So look, if I replace x with p, so if I plug in p, right? Because this is the equation from that parabola. So if these points have an x value of p, to find their y value, what do I need to do? Just plug in p for x. So if I do that, what does this become? It becomes y squared equals to 4p squared. Now if I square root it, what do I get? I get y equals to plus or minus 2p, which what is this saying? From the x-axis, move up 2p units, and then also move down 2p units, which gives you a distance of what? A total of 4p. Now look at how nice that is. 4p is the same thing as this. So in other words, what are we saying? When you look at your equation, you automatically get the length of the focal diameter for free, right? So what we can then say, look, notice how then the length of the focal diameter is absolute value of 4p, because we don't want obviously the negative, right? So basically what we're saying is, look, whatever 4p is, half of that, if you travel half of that up and down from your focus, you'll locate 2 points on the parabola, which then what does the focal diameter do? It lets us see how wide a parabola opens, right? So remember, if you just graph a parabola with just a vertex and no other points on it, and you just draw it opening to the right or to the left, I can argue, well, wait a minute, how do you know how wide the parabola opens up? And what's going to help me find the width or how wide or narrow it opens up is the focal diameter. So the focal diameter, you don't necessarily need it, but it's a nice quick way when you're asked to graph parabolas. It's a nice quick way of being able to sketch the parabola without having to do much work, because it's already embedded into the formula, right? This 4p that we're talking about is the same as that 4p, right? So it's very easy to work with. So if you're wondering, hey, why are we even talking about the focal diameter? It's just to make our lives easier, right? It's a nice characteristic of the parabola that we have here. So for example 4, let's do this. Find the focus, directrix, and focal diameter of y equals to 4/9 x squared. And then we could say and graph, which you'll see in a minute why the graph of it's very simple once you find all this information. So what I want to do is I want to put this in the form that we've been working with in this class. So what is it that we know? We know that this is a parabola that opens up or down, and it definitely is going to be up because there's no negative here. But what is it that we know? Y equals to 4/9 x squared is the same thing as what? X squared equals to 9/4y. Once again, I'm just writing it like this. We don't have to. We can still work on it in this form. It doesn't make a difference, right? So here's what I know. This parabola opens upwards, right? And we need to figure out what P is. And by the way, before we even do that, isn't this, what's 9/4? That's my 4P, isn't it? So right away I could say, look, the focal diameter is what? 9/4. Okay? So, with that said, that's my focal diameter. So now what do I need to do here? I need to now find the focus and the directrix. So now I need to find what P is. So just like before, I'm going to say 4P equals to 9/4, which if I solve for P, what do I get? P is 9/16. So if that's the case, if P is 9/16, what do I know from my vertex? And by the way, my vertex, once again, this format, whenever it's in the x squared equals to 4py, that's always 0, 0. So if the vertex is at 0, 0, the focus, I'm going to move up now, will be where? At 0, 9/16. And then what would the directrix be? I would have to travel down, so that would be, the directrix will be at y equals to -9/16. Okay? So now, if I'm asked to graph this, what does that mean? What that means is I need to first plot my vertex, and then the focus. So if this is, let's say, 1, -1, 1, -1, the focus I'll have to travel where? 9/16, which is a little over halfway up. There's my focus. And then the directrix is a little over halfway down from 1. So something like that. And then see, now I need 2 more points on my parabola to graph this. And well, the good news is what? I could use the focal diameter. But since the focal diameter is 9/4, from the vertex, or from the focus, I'm going to need to travel right and left half that distance, right? Because remember, the focus is the halfway point. So I'll travel which way? Half of 9/4 is what? It's 9/8. So I'm going to travel 9/8 to the right, which is what? A little bigger than 1. And 9/8 to the left, which is a little to the left of -1. And now notice with those 2 points, see, I used the whole idea of my focal diameter. With those 2 points, I could now graph the parabola, and we could see how wide it opens up. So see, the focal diameter, the nice thing is it allows us to easily graph these parabolas. Okay, so you don't need them. You can plot some random points if you want, but I feel like the focal diameter does a very good job of determining if a parabola opens, how wide it opens up. Okay, so the last example I want to do is kind of, it's a word problem, which is an application. So we would say that a searchlight has a parabolic reflector that forms a quote-unquote bowl. We would say then which is 18 inches wide and, or from rim to rim, and 10 inches deep. If the filament of the light bulb is located at the focus, and I'll explain to you guys why that is the way it is in a minute. How far from the vertex of the reflector is it? Okay, so basically what are we being told? We're being told that we have a light, right, a searchlight that's in the shape of a bowl that looks like a parabola. So this is kind of like a 3-dimensional paraboloid, right? But we can break this down to a 2-dimension. So here's what we're doing. We're being told that, hey, what you're dealing with looks like a parabola. Now, which way it opens, where its vertex is, it's up to us to figure out. That's not the issue here, right? So I'm going to draw out, and obviously if it's always up to me to pick where the vertex is, origin is the best place to put it, right? Because it just makes the formula so much easier to work with. So basically what they're describing is, look, whatever this bowl is, it has the shape of a parabola, and I'm going to put the vertex at the origin. Now you can decide, do you want it to open to the right, left, up, down? It doesn't matter which one you use. It'll just, the formula will look slightly different, but our end result will be the same. So I'm going to draw a parabola that opens upward. And what are we being told? That the rim, this is 10 inches deep, right? And then what are we being told? It's 18 inches wide. So that's 18 inches wide, okay? And since I put the vertex at the origin, we know that the y-axis is my axis of symmetry. So clearly, if this whole thing is 18, this half is 9 inches, that half is 9 inches, right? Because it cuts it in half, okay? So think of it this way. We're saying, look, we want to put the light bulb at the focus. So the light bulb is at the focus. So this is where the light bulb is. Now, why is it that parabolas, we want to put things at the focus? Because the focus is what causes, or it's the ideal location to put this, because the light beams are going to bounce off of the parabola, which is the reflector, and they're going to move straight, right? It's kind of like, so you're going to get your maximum light if you put, or the range if you put the light at the focus, right? If you move it elsewhere, it'll bounce off and go in different directions, right? It's kind of like, another example I could give you is, if you ever look at satellite dishes, what do they look like? Don't they have parabolic shapes? And where do they put the transmitter of a satellite dish? They always put the transmitter somewhere in there if you look at it, because the information bounces off the satellite and goes to the transmitter. And guess what the transmitter is? That's where the focus of that parabola is. So it's kind of like, that's where it gets the name focus from, because when you have something of a parabolic form, when something bounces off of it, it'll always go towards the focus, right? So we want to pretty much design it in a way where the light bulb is at the focus, because then that'll give us the maximum range. So that's why they're saying, hey, if the filament of the light bulb is located at the focus, because that's where these flashlights are always designed. So if you have a flashlight at home and it has a reflector that's of the shape of a parabola, you'll notice if you look at it, the light bulb will literally be at the focus. So if they're saying, look, how far from the vertex of the reflector is it? If this is the vertex and that's the light, I need to find P, don't I? That's literally what P is. So the key to answer this question is I need to find out what P is. So to be able to find out what P is, I need to find out the equation of this parabola, right? Because the parabola, the 4P, the P is in there. Now the way I've drawn this parabola, the equation I want to use is what? Or the equation I'm going to use is x squared equals to 4py. Okay, so the problem is this. I don't know what P is. But if you think about it, we have information in this equation or in this picture to help me find P. Now, obviously, the vertex is a horrible choice, a horrible point to use. How come? Because the coordinates are 0, 0. So when I plug in 0 for x and 0 for y, that's going to zero everything out. That's not going to be helpful. So here's the other thing. This equation describes all points on the parabola. Now, if I could only find another point where that's on the parabola, then if I could plug it in for x and y, I know that this equation is going to be valid, which will allow me to solve for P. So if you come back to this, what you'll notice is, wait a minute, we could actually locate two other points on this parabola that we know exist on it for sure, and we know it for a fact, which is that point. So what's that point going to be? Well, look, what do I know about its y value? Its y value is clearly 10. And what do I know about its x value? We said, well, if the whole bowl is 18 inches, the way I've placed the vertex, this would be what? 9 units, like I said earlier, 9 units to the right. So that's 9. Or the other point you could use is what? You could say -9, 10. It doesn't matter. So pick any one of these 2 points, which I'm going to go ahead and pick this one. What do I know? If I plug in 9 for x and 10 for y, that equation will still be valid, because this point is on the parabola, and this equation describes that parabola, then I'll be able to solve for P. And once I solve for P, then I could answer the question, right? Because remember what we said earlier, we need to find P. P is the distance from the vertex to the light bulb, which that's where they're saying, where's the light bulb located at the focus? How far from the vertex of the reflector is it, right? So P will tell us how far it is. So if I plug in 9 for x, I get 9 squared equals to 4p times 10, which what does this give me? It'll be 81 equals to 40p. And if I divide by 40, I get p equals to 81 over 40. And this is all in inches. So there you have it. So what is it that we're saying? The light bulb is 81 over 40 inches away from the vertex of the reflector. Okay, so in this problem, if you notice, we just needed to find the length of the length, which is literally what P is. Okay, so this pretty much takes care of this section. Please do not hesitate to reach out to me if you have any questions. If there's anything you weren't sure about or anything you need me to touch up on, please don't hesitate to reach out to me. I'll be more than happy to help clarify any questions you may have.